So one thing you should know how to do is find the area of a circle. And not just find the area of a circle, but you should be able to find the area of a piece of the circle. So to find the area of a circle, you would find, basically what we're looking for is, we don't want just the distance around it like we talked about with circumference. Now we're gonna cover that pizza with cheese. So not just the crust around the pizza, but we're gonna cover the pizza with sauce or cheese. And that is what area represents, the square units that are enclosed inside the circle. And we find that by taking pi times r squared, and r is the radius. So it's confusing because circumference is 2 times pi times r, and area is pi r squared. So there's a 2, there's a pi, and there's an r in both equations, so you have to be careful. 2 times r is different than r squared, which is r times r. So be careful with that. So area is pi r squared. Now, just like when we talked about the sector or the arc length, how it was just a piece of the circumference, the sector area is just a piece of the area. Well, how do we figure out what the piece is? Well, we do the angle that is incorporated into it over 360, because 360 is the whole circle. So again, it's part over whole. And then part, the shaded section, right? That's what we want, is the shaded piece over the whole area, pi r squared. So let's look at some examples. So I have this circle. It's always assumed that we want the small sector. If it isn't highlighted, if it isn't shaded, then it's always assumed that we want the little piece. So I want the area of the whole circle. So the area of the whole circle, area is pi times r squared. So we would do pi times 4 squared. Well, that's 16 pi, or you can type it into your calculator. 16 pi would be exact, and then 16 pi, 16 times pi is 50.3. So my area would be 50.3, and that's meters squared. Area is in units squared. So the area of the sector, well, this is 90 degrees. It's 90 degrees out of 360 degrees. That's the part, that's the piece that it takes up. So I want to know how much area does it take up out of 16 pi. We just found the area, so now I know what that is. So we can do 90 divided by 360 times 16, and you get 4 pi, right? 90 divided by 360 times 16 pi. If you don't do pi, if you just do 90 divided by 360 times 16, you get 4. And then 4 times pi would be 12.6. Well, if you take 50.3 and divide it by 4, because technically, right, this is 1/4 of the circle, you get 12.6. So that's kind of logically, it makes sense when you're looking at quarter circles and half a circle. But we use the same math when it's an angle that we're not so familiar with. So the area of this circle, area again is pi r squared. So we do pi times 12 squared. So if you type in pi times 12 squared, you get 452.4. So if I want the area of a sector, or this was 144 pi, right? And so that's called exact. If we leave it in terms of pi, then it's called the exact. So the area of the sector, again, unless it is already shaded, we assume we want the small piece. So it's 60 degrees out of 360 degrees. You can use the formula, right? You've got the formula right here. It's 60 degrees out of 360 degrees is equal to the area that I want over, we just found the 144 pi, or the 452.4. So if you do 60 divided by 360, y'all, that reduces to 1/6, by the way. So this is 1/6 of the circle. So you could just take the area, 144 pi, and divide it by 6. You could do that. You could do the same thing, right? Over here, we did 16 pi, and it was 1/4. 90 over 360 is 1/4, so you could divide it into 4 pieces. So that's just another way that you can think through it if you're good with logic math. And then times 144, you get 24, so it's 24 pi, or you can do 60 divided by 360 times 144 pi, and you get 75.4, or 452. If you do 452.4 and divide by 6, you get 75.4. So it's the same idea. Most of our answers are going to be rounded, but I just want you to see what having an answer in terms of pi looks like in case you ever see it somewhere else. So let's look at this big circle. In this case, I want the area of the shaded sector. So I want the big piece. Now, one thing you do have to pay attention to is the 40 degrees is this small piece, but I want the area of the big piece. So that means I need to find the angle for the big piece. Okay, so the angle of the big piece, the whole circle is 360. So the angle for the big piece is 320. So the area of the shaded piece, okay, you can do this all in one step. You don't have to find the area first. It's 320 divided by 360 equals the area that I want over the whole area. Well, the whole area would be pi times r squared. That's the whole area, right? It's part over whole. So you would type in 320, and however you want to see. I've been saying it a particular way, but you don't have to. You can do 90 times 16 pi divided by 360. You can do 60 times 144 pi divided by 360. So you can do it that way, or you can do 60 over 360 times 144 pi. You can do 320 over 360 times 81 pi. Okay, so it kind of just depends on how you see it and how you want to do that proportion. So if I type it in, 320 divided by 360 times 81 pi, then I get 226.2 meters squared. That's the area of the shaded section. So just so you kind of know, 81 pi, the whole area is 254. So the area is 254.5. So 226.2 makes sense because it's a big piece of the circle. If you got a really small number, then you would know that you did something wrong. Now, this is a review, length of ACB. ACB is this big arc. I want to know how long it is. That's what we learned in the previous lesson. So it's the same. Look at the how similar these equations or these operations are. So it was 320 out of 360 degrees. So how far is it out of, now this time it's 2 times pi times r, right? There's your difference. This one's for area, this one's for length. And so you use the exact same, it's almost the exact same formula. The only thing that changes is the whole. Do I want the whole distance around, or do I want the whole area? So I can type in 320 divided by 360, multiply that by 2 times pi times 9, and I get 50.26 or 50.3, and that's meters. Length is in meters. So it comes back to these formulas again. Area is how much space is taken up or covered by the shape. The sector area is a portion of the circle. So we're dividing the circle into equal pieces, and so that's the portion that we want. And you can use this formula using part over whole. So these two, this last one is a good example of how you're using that similar formula, but all you're changing is the piece that you need.